Hey there, it's Mr. Dix, your homework buddy. I'm gonna do your homework with you and help you out, be your little thought partner. I'm gonna break these up to some separate videos. I'm thinking it might be a little long. This is a hard problem. So let's get started. Let's do the first 10 together. We're gonna translate the verbal description into an algebraic expression. And then we're gonna simplify when possible. Okay, so the sum, so I know it's adding, right, of 1/6 x and 2.8. That's how I would write it as a fractional coefficient. You could also put it as x divided by 6, but divided by 6 plus 2.8. Can I combine these? No. We have a numerical term and an algebraic term and numerical term. So we have to stop there. That's all we have to do. All right, 1/2 of u subtracted from 3 times u. Okay. So I have 1/2 of u subtracted from 3 times u. Let's draw it like that. Here we have 1/2 u subtracted from 3 times u. So 3u minus 1/2 u. Okay, am I done? No, I need to simplify this, right? I can simplify and combine these like terms. 3u minus 1u. I know that's 2.5 u, but we don't, as we learned in the first couple lessons, you don't do a mixed number for a coefficient. Do you know what that would be? How many halves is that? 2.5 is how many halves? It is 5/2 u. Okay. All right. Let's keep going. 4.5 times q. Okay. Decimal coefficient. Divided by 9. Anyone think of that as 4.5q divided by 9? Well, what could we have? That's the same thing. I love thinking about this different ways. I'm like doing some gymnastics. Like, well, I don't like that as a fraction. So I'm thinking, what if I doubled this to get the top to not be a fraction? What if I just doubled both of these, like an equivalent fraction? I'm laughing because like I'm going to do all these steps and it's going to be satisfying, but you didn't have to do it this exact same way. If I did it like that, then I would have 9q over 18. Do you know what 9 divided by 18 is? You could write this as 1/2 q, or as a decimal 0.5 q. Sick. Okay, fun. This you might be thinking like, oh, can I combine like terms here? I just wrote it as this. Well, with multiplication and division, you can multiply and divide algebraic terms. It's not adding and subtracting. Adding and subtracting where we can't combine like terms. So that's kind of tricky. Let's see if we can see more examples of that. 60% of 1/2 x. If you think of 60% as a decimal, that would be 0.6 or 0.60. 60% of is like to multiply 1/2 x, right? So basically what I would do is I would multiply these two factors because 1/2 x is still multiplying by x. 60% of a half, or a half of 60. 60% of a half is the same as a half of 60%, and that would be 30%. So I can write that as 0.3 or 30, 0.3, and it's going to be x. Woo! Let's keep going. All right. This is the one I'm seeing who watches this video, because this is going to be hard. Let's 5x increased by 120%. Let's pretend this said 100%. What is 5x increased by 100%? That's almost thinking about like doubling it. Like I had a certain amount and then I increased it by that same amount. So 5x increased by 100% would be 10x. Because think, if 100%, this might be too small, 100% of 5x is 5x. If I increase it by another 100%, that would be another 5x. So cool. I know it's going to be more than 10x. If I do 5x increased by 120%, that's going to be 5x plus 5x, which is the original amount increased by 100. What's 20% of 5x? 20%. I don't know. Like, how are you going to best understand this? 20%, I could do it as a fifth, but 20% of 5x is the same as just x, or 1x. So 5x increased by 120% is 11x. This one's so hard. Increasing by a percentage, oof. This is why that problem's probably why I'm making this video. All right, 7 times z reduced by a third of the product. Reduced by a third of the product. 7 times z reduced by a third. Whew. So not a third. We're going to pretend this is the amount, and we're going to chop off a third of it. So low key, that is basically, if I'm reducing it by a third, I'm finding what is 2/3 of it. I just have to laugh because that is so hard to understand. It didn't ask what is a third of the product. It says reduced by a third. So I have 7 times z, and I'm going to chop off a third of it. So that's going to be, I'm left with 2/3 of it. So that is 14 thirds z. Some of these people that aren't watching this video, just for funsies, ask them, oh, you didn't need the video? Okay, what'd you get for number 6? It's hard. Okay, maybe number 7 will be better. I don't know. 24% of W, I'm going to put that as a decimal. 24% of W plus 50% of Y. That's it. We can't combine them. 3/4 of V subtracted from 6 times, I need the parentheses, 2/9. I wonder if Y goes on the inside or not. Doesn't matter, probably. Boom. Can I simplify this? Yeah, I can use the distributive property. 6 times 2 is 12/9 Y minus 3/4 V, and technically 12/9 divided by 3, 4/3 Y minus 3/4 V. All right, we'll keep it rolling. We got a couple more minutes in this, and then if you need help with the rest, I'll make another video. 1/4 of the sum of 2p and 11. Now, Should I leave it like this? I could. Or I could use the distributive property. Think about what that would be. A fourth of 2p. 2 divided by 4 is 1/2 p. Plus a fourth of 11 is 11/4. Nice. Last one. The sum of 2x 2/3 x plus 5, we can put in parentheses, and 11 minus x. I know some of you guys are going to get away with like, oh, I'm done. This says simplify the expression. So let's combine them like terms. X minus x, negative x. Well, let's just take this x away right now from here. 2x minus x is just x. Plus 2/3 is going to be 1 2/3. Instead of 1 2/3 x, how can I write that? 5/3 x. Dun, dun, dun. 5 plus 11 is 16. All right, that's it. See, that didn't take that long. That was just 11 minutes on 10 problems. Okay, let's see how we do in the next one.